we're going to go ahead and finish up the electricity portion, part 1. So we have a triboelectric series here. Let's remember that we have these positively charged. Well, nothing's positively charged. Everything in here is neutral. However, when things rub against each other, we have an exchange of charge, or rather a moving of charge from one object onto the other. And specifically, the lower down you go, the more greedy the substance is for negative charge. So, for example, if I rub rabbit fur against human hair, the human hair will acquire a negative charge. The rabbit fur will acquire a positive charge because the human hair picks up electrons from the rabbit fur. So, here we go. A physics teacher rubs some PVC pipe with paper. We want to know which statements are true. So if we rub the PVC pipe with paper, PVC is going to end up being more negative, and paper is going to end up being more positive, so that's how we are going to figure this out. So if the paper does become positive, that means it will lose electrons, so this is true. The PVC pipe will not become positively charged. It will become negatively charged since it's lower on the triboelectric series. Charge is never destroyed. If the paper gained a charge of +5 units, then the PVC acquired a charge of -5. That is correct because charge is conserved. False. We always obey conservation of charge. The electrons are transferred from PVC to paper. False. That would give the paper a negative charge. Once charged in this manner, the PVC and the paper cloth should attract each other. They absolutely should because they have opposite charges. In general, PVC materials must have a greater affinity for electrons than paper materials. That is in fact true. That's exactly what electrode negativity means. All right, moving on to the last page. We want to determine the resistance of each circuit and the total current put out by each battery. So, circuit 1, they are in parallel. So we have 1 over R total equals 1 over R1 plus 1 over R2. And this is going to give us 1 over R total equals, I'm just going to write 1 over 4 plus 1 over 12. And I'm going to write this as over a common denominator. That's going to be 3 over 12 plus 1 over 12, which is going to be 4 over 12. Taking the reciprocal, we're going to have R total equals 3 ohms. So that's part A. For part B, we'll use Ohm's law. V equals IR. So that's 12 equals I times 3. And so the current that we get through this circuit is going to be a total of 4 amps. And then for circuit 2, our total, we actually add them up when they're in series. So that's 5 plus 3. That's going to be 8 ohms. And so when we simplify the total, then we'll use Ohm's law, V equals IR, and we'll get that 8 volts from the battery produces a current that gets run through the 8 ohms of total resistance, and the current ends up being 1 amp of current. So this completes our practice test, and I will provide solutions to the second practice test as a PDF. So this should give you a good basis to study.